Are you guys here? There are people from Landover group here? Anyone from Landover? Okay. Anyone from Buffer?
We hear Gaitan, but
Sure.
not all the members are here yet. Still missing like 3 or 4 people.
Okay. So, okay, those who are here, you can start. Okay. You can start whenever you guys are ready. Okay. You can start.
All right. Let me share them. Okay, Natalie, you want me to share? And then
Ms. Grenada, please make me as a host, please, so that I can manage the people. Thank you.
If you can, Gaitan, let me share, please.
You can share, sir.
Okay, thank you. Okay, let me see. All right, Natalie.
Hi, Mr. Patrick. Yes.
Yeah, how are you? You want to start since John is not there.
Yeah, we have a good number of our team members missing. About 6.
Yeah, he wants us to go ahead.
Start with just the 3 that are connected.
Yeah.
Okay.
Let me go ahead with the presentation, and then I will start. All right, Gaitan, since we're missing people, I guess we're not gonna start at the beginning.
Yeah, just scroll ahead to
the first slide are not there yet. So we're gonna jump back and forth.
Okay. Then wait 10 more minutes to see. If not, okay, so that
Okay.
30, if they are not there, you guys can just start and do
Okay.
whatever. I don't know.
Okay, sir.
All right, thank you.
Yeah, let's wait 10 more minutes and see.
Okay, thank you.
Okay?
All right, thank you.
Okay, sir, thank you.
All right, thanks.
You guys should call on your colleagues, please.
Fali is here. Pius.
Yeah, Fali
Can
is
you
here.
please reach out to
yes, I'm doing that now.
Can you reach out to Devon if you can? Yeah.
Sure.
Shawin is here, man.
Yeah, Devon is there.
Darwin is here.
Yes, ma'am.
Okay.
You guys should call Mr. Jones, please.
Okay, I'll call him right now.
Okay, thank you.
Oh, let's see. Let's see. Hi, Gaita. Hello, Gaita.
No.
Do you have more members?
Yeah.
One or two, or we can start with that, right?
Yeah, we can start. Natalie, you want to present?
So hello guys. We are the buffer team. Normally a group of 10 members. Unfortunately, not all present right at the moment. Today we'll be presenting. We'll be doing a presentation on 4 topics, and of course that relate to performance tuning. Before we start, what is performance tuning? Performance tuning is just simply just making simple the process of accessing and changing information within the database with the intention of to improve the query response time and the application operations. We have 2 types of performance tuning, the proactive and reactive. The proactive being a mechanism that helps us, that is set up to help us prevent some occurrences that may keep the database from performing at its highest capacity. And the reactive is the process of fixing the issues when they already occurred. Today we'll be talking about materialized views, AM and ASMM huge pages, and I believe the last one is partitioning. Yes. Performance tuning happens at multiple levels. We'll start with materialized view. That is performance tuning at the level of the application. And to present on materialized view, I will have Idalite.
Yes, Natalie.
And Pius. Idalite will do the theory part of it, and we'll have Pius do the practical part of it. Go ahead.
All right. Thank you, Natalie. Good morning, class. Good evening, class. I'm going to emphasize on the materials view, which is one of the base on Oracle tuning. We all know performance tuning, as Natalie was saying, as a proactive and reactive set of proactive and or reactive measure taken by the DPA to ensure that a particular statement or a particular sequence statement or the entire database is falling as fast as it should. So one of those proactive measures here is to create a materialized view, which can give us a fast access to our data. So here we're going to see what is a materialized view and what is it used for, how does it work, different type of refresh, main refresh trigger, and also the advantage and the disadvantage to be using a materialized view. So a materialized view in Oracle is we can define it as a database object that can contain the result of a query. It contains periodically refresh based on the query or against a local remote table, in which case we need a database link. It is also good to mention that materialized view, which store data based on the remote table, are also known as a snapshot. How does it work? Or how does a materialized view improve performance in Oracle? Here we have two different cases. You can, first of all, you can use materialized view to increase the speed of query on a very large database, because query large database often involve join between table aggregations such as sum or both. It's also important to notice that the materialized view, the type of the materialized view you create determine how the materialized view is refreshed, and how does it use by query rewrite. Materialized also view also are there to decrease the query execution time by pre-computing the result. So it means that as you are getting the result that are already calculated, there is an issue of slight variation with your actual data. But if you are aware of how the underlying table are changing, then you can use materialized view for a really great effect. Another use of materialized view is that you cannot perform a GML operation on a materialized view, but you can perform DGL operation like drop, like for example, daily load, monthly load, yearly load, on all those cases. Now I'm going to talk about Mr. Patrick. Can you go? Yeah, oh, thank you. Okay, now we're going to see, I'm going to start to talk about when to refresh before talking about the main refresh and refresh, the different refresh, main refresh and refresh trigger. We're going to say that about the refreshing, there is never a best time to refresh material view. It's mostly depend of the environment that where you are working, or their need. And another thing is that the refresh method can be incremental or complete. You can be incremental or complete. So first of all, we're going to talk about the main refresh strategy. The main refresh strategy, the refresh method can be okay, sorry. About the main refresh strategy, we have three types. It can be fast, complete, or false. As fast refresh, in case if the material view log are not present against the source table in advance, the creation table will fail. In complete case, when you do a complete refresh, the table segment supporting the materialized view is truncate or repopulate completely using the associated query. In false, a false refresh is attempt. When a false refresh is attempt, if a false refresh is attempt when you cannot have a it's not possible to perform a complete refresh. Now we're going to talk about the refresh trigger. The refresh can be triggered in one or two ways. The first way is on commit, and the second way is on demand. When a change is for on commit, when the change is made, it refreshes immediately, so you don't have to do a manual refresh. Like when if you put the new information on the table, the refresh will be uploaded immediately. But it has another disadvantage is that it's an intensive work, so it's going to take a lot of resources. On demand, you can, when you change information on the master table, you have to do it manually. You have to do the refresh manually, or you can schedule. You can request this. You can schedule it as you can schedule your task to be able to refresh it for you. Okay, now we're going to see the benefit of using a materialized view. We previously saw that a materialized view can be used to improve the performance of a variety of query, including those performance aggregation and transformation of data. Allow to work. The work is allowed to be done once and used repeatedly and multiple sessions, reducing the total load on the server. It is also used for a remote replication. Okay, I'm going to talk about the disadvantage to be using a materialized view. The first that we saw here is that we cannot perform a DML operation on a materialized view because it is like a snapshot or a read only. It is mainly used for reporting purpose. A materialized view can either read only, updatable, or writable. So we can just perform a DML when a DML on updatable, on writable. On readable, we cannot perform GML too. We can to perform GML in that case, we need to create a materialized view by using update clause, and it has to belong to a materialized group. We can conclude that materialized view is a powerful database solution that allows us to access the views data faster. Also, the materialized view query is executed once when the view is created, not when accessing the data as it is when it's in a regular database view. So Mr. Pius is going to present us how to the practical part of it, like how to create a material view and how to manage it.
Okay, thank you, Idileta. I'm going to share my screen now. My name is Pius. Good evening, class. I'm going to be creating a material views for class 26. Okay, let me share my screen. Okay. Can you guys see my screen?
Not yet.
Not yet.
Not yet? Okay. No. Let me go back. Maybe I did something. Okay. Is that okay now?
Yeah, you're good.
It's good now.
Okay, I'm going to be creating a materialized view, like I said, for class 26. I'm going to be using one of the refresh methods, which is the complete, because I don't have the log. Like she said, you have three types of refresh method. The first method, the complete, and the false, which is the complete and the fast together. So with the false, when you try to do a refresh, if you don't have the logs, it's going to trigger, it's going to do a complete. So I'm going to be doing the complete. The false, in my script, you're going to see the false, but the false is going to do a complete because I don't have the logs. Okay, so creating a materialized view, you start by creating a user and giving that user the right privilege to create a materialized view. So my user today is going to be class 26. Okay, so let me see. Oh, sorry. What happened? Okay, there's one. Okay. Yeah. The privileges for class 26 to be able to create a materialized view. My computer just freeze on me. Sorry about it. Sorry, 1 minute. My computer just freeze on me. 1 minute. Oh my God. Sorry, my computer freeze. Let me do something.
It's good. You need somebody else to take over, or you think you
No,
can run the issue.
I think I'll get it.
Okay.
I don't know what happened, but let me just do something. Okay. Okay. So I'm back. All right. So I'm going to be using a little table so we don't have to wait too long for the table to update, or when you query the table, you can get your result faster when using a little table. So I'm going to be using a Scott.d department. Okay, 1 minute. Yeah. Oh boy. I don't know why my computer keep freezing on me. Oh, boy. Okay. So oh my God. Oh boy. Sorry, I don't know what's going on with my computer today. So I wanted to select the table to see what is on the Scott department, so I know what kind of view I'm going to be creating. So just a very little table with only four rows. Okay. So let me see. Okay. So this table only have 4 rows on it. So I'm going to connect as class 26 to create the materialized view. Okay, let me see what is on Scott the department. Okay. 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 View ISM materialize view MV3. Yep. V3. Enter. Okay, so I'm gonna use the force refresh type. I'm gonna use force, yeah. Force, yep. And then I'm gonna on demand so that I can see the right away. On demand. There. And then as select. Let's see, depth now. Department number. D. From Scott. In the department number must, I didn't get it right. Hold on.
You got a typo.
Okay.
DN, it should be DN.
Okay. Okay, let's see. So let's select. Like, so it should be DN.
I think it should be DN.
Okay. Okay, yeah, DN. Okay, I'll put the M. Okay, I see.
Yeah.
DN. Oh, it's still missing something. Line 2.
Mr. Paz,
Yeah.
I think you're missing, and after you put to refresh, you have to put to the building immediately. We got two options to building.
Okay, let me do this one.
Immediate.
Okay, let me do this one. You see, I'm missing, let me see, refresh, line 2. If I say that again, what am I missing?
I think you're missing the close option. the close
Whenever
option.
you are copying on Poly, copy one line at a time. Never copy with the numbers.
Okay, 2 line. Okay.
Yes, you copy the first line.
Okay.
You copy the second line. Don't copy number 2. Copy the second line. Yes.
Okay.
Paste it and do the same for everything.
Okay. Thank you. Okay.
Yeah, it's good. It's good, but I don't see the way you put it building immediately. It's
Okay. On demand. And then and then
No. Why you put that one?
okay.
That's it.
Okay, that was it. Okay. That's been created. Okay. Okay, let me select that view now. Select. Class 26. Okay. 6 dot and V3. Keyword. Oh, no. From. Okay. 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 Just select all from. Okay. I missed that. Sorry about that.
You're good. You're good,
Okay.
Charles.
Okay. So that's the materialized view that I just created. Okay. Next thing. Okay. Let me see. This one. This one. Okay. Let me connect. Okay. I'm gonna use this materialized view to give another user so they can be able to view it. Because you can give a view for another user to view. So I'm gonna be using a HR as a user. So first I have to grant HR that privilege to be able to view it. So I'm gonna unlock HR first.
The correct is that.
Okay. Okay, now I'm connected as HR. Let me try to view it. Let me see. Okay. You see, that's HR. So you see, I've just granted this view to HR. Like if you like working for a company and security just needs the new hires driver's license number, the kind of car they drive, so they can give them a parking sticker. This would be a good way to create a view for the information that security needs. So when they hire, so when the new employee comes, they can be able to use that view to view the information to issue them a parking pass. Okay. So, Connect. Just 1 minute. Okay, just 1 minute. Okay, let me see. I just view set it up. Just 1 minute. Let me wait something minutes. Just 1 minute. Select just 1 minute. Just 1 minute. Okay. Okay, I'm gonna be updating that table. I'll change some information on that table, like I'll change like this ID. I'll change this ID and do a refresh so you can see on the view how after refresh you can see the change on the view. Okay, so.
Okay, thank you, Pius. While you're working on that,
Mm-hmm.
for the sake of, no, you should just go ahead. For the sake of time, we'll only be demonstrating how to create a materialized view using the build immediate clause and using the force refresh.
Okay.
Like I stated earlier, the force refresh will first attempt to do the fast refresh, but since he doesn't have the materialized view logs created, it's going to go ahead and do the complete refresh.
Okay, thank you.
So once you update the information on the source table and you run the DBMS package to refresh the materialized view table, we'll move along with the presentation.
Okay. Let me see. Let me see. The updates card, the MP set depth now equals to 60. Let me see. Table of view does not exist. What's going on right here?
I think, Mr. Paris, I think you connected to the HR. That's
okay,
why.
I'm still connected as HR. Let me connect back as class 26. Sorry.
Okay.
Mm-hmm. Okay, thank you. This he says it does not exist.
No, Mr. Paris, because
no, okay, sorry, class 26. So sorry, I created this view as class 26. Okay, let me connect as class 20. Sorry.
No problem. You're good. You're good.
Okay, got it now. No, copy the wrong one. Sorry. Insufficient privileges. Did I give? Let me see.
I think, Mr. Paris, you have to give you the 26 the privilege. You will see this table now, Scott.
Well, class 26 is the one that created this view. Or to see the Scott.
Yeah,
okay.
To see the Scott table, DMP.
Okay. I think 6 dBA.
Connect.
What? I didn't hear you. Just exit and get back. I'll just exit and get back. Okay. I have to give class 26 that's grant. Fadi.
Yes, sir. Yes, sir.
So, what did I miss? I have to grant class 26.
Yeah, go and select and update. You want to update? Select or update to class. Select and the update on Scott.dmp to class 26.
Grant, select, like update.
You can make it comma, select, comma, update. No, typo.
Yeah, I see. Update.
Okay, Pius, not to cut you, but it's taking a bit long, and we can always come back to it. We'll move along with the presentation, and during questions we can always come back to that. You have the chance to put your script together, and if we have the time or the chance to come back to it, you can run it and show how it's done. So next we'll be talking about ASM and ASMM and AMM. And we'll have Mr. Patrick.
Okay, let me stop sharing.
Mr. Patrick, yes, please. Let's move along to the next topic. Thank you. Go ahead, Mr. Patrick.
Hello, class. I'm Patrick. I'm from the buffer team. I'm going to be presenting AMM and ASMM. Because the two are related, I think I will talk about both at the same time. So what is AMM? AMM is automatic memory management. And before that, AMM and ASMM are both memory component. So AMM enable you to specify memory allocation, memory allocated to the instance, including the SGA and the PGA. So the memory will be dynamically reallocated between the SGA and the PGA as needed. Also, AMM is available on only those platforms that support dynamic release of memory. So when AMM is enabled, ASMM is automatically enabled. What about ASMM? It stands for Automatic Share Memory Management. So ASMM enables you to manage the SGA as a whole. So it comprises several components: share pool, large pool, Java pool, DB cache, and stream pool. So the size of many of those components, which I just mentioned, are dynamically adjusted for the best performance within the limit of the initialization parameters. How are AMM and ASMM related to performance tuning? So both AMM and ASMM have what they call memory advisors, and they are available to help us set the initialization parameter on various levels based on the workload. Also, you can use the memory advisor on OEM for the specific component to determine appropriate new settings. Oracle recommends to use ASMM to simplify your memory management task. How to manually manage AMM and ASMM. First, if AMM is enabled, only the memory size advisor is available. So you can increase the memory max target. So if you do increase that memory max target, you must restart the instance. Also, you can increase the memory target, which are part of AMM. And when you increase the memory target, you cannot, the value you specify for that memory target should not be greater than the memory max target. If ASMM is enabled, but not AMM, the SGA size advisor is available. So you can increase the SGA max size target. You can also increase the SGA target, but when you increase the SGA target, again, the value you specify cannot go great. It cannot be greater than the SGA max target. So, like I mentioned earlier, you can change the size of the memory max target or the SGA max target from OEM. You can also do that from PuTTY. So on PuTTY, you can use the alter command to change the size of the memory component. For example, you can do alter system set SGA underscore target equal 300, scope equal SP file. And then you make sure you restart the database for it to for the change to take effect. Other recommendations. Before enabling ASMM, you should remove the individual memory parameter from the SP file before having them set. Before having them set can impose restriction on ASMM. And one of the restrictions might be a specific block number or block size. When you decide to adjust or change value in the respective component, if the value is lower than the current value, that value will be treated as minimum memory size, excuse me. So if we go to OEM, like we're gonna do shortly, and then we change the value of, let's say the memory target. When we log on, and then we see, for example, if it's 50, and then we decide to put 100. So Oracle going to consider that 100 to be the minimum value. So if the value is larger than the current value, the size of the memory will be resized upward. So doing this will limit the amount of memory available for automatic adjustment. So again, when we change manually those values, it will limit the AMM and ASMM to adjust the size of the memory. And now we can do how to, we can see how to change those components manually using, first we're going to use PuTTY, and then we're going to go to WinSCP. So I log on to SQL. So first, I want to check the memory max target. The memory max target and the memory target. Show parameter memory. Okay, I can see here, as we see, the memory max target is 0. So I can decide to alter the database and give a value, add a value, set a value to memory target. So I will do alter system set memory target equal. So like we saw, I cannot give a number higher than 400. So it should be less than 400. So I will give like 150. Scope equal SP file. Okay. Also, let me, before I restart the database, let me show also the PGA aggregated target and see the value. Show parameter SGA. So as we see, SGA max target is 400. So and SGA target is 0. So I can alter the database and give him SGA target the value. I'll do the same thing. Alter system set equal. Again, like we mentioned, the maximum is 400, so I cannot go past 400. I should give a value less than 400. So I can do 152. Scope equal SP file. Okay, I will restart, shut down, restart database for it to take effect. Sure.
Why does it create P5 from SP5 before doing that?
I can do it after. You don't. It's still fine.
Okay.
You're right, below. I can do it both ways. So while this is running, okay, I'm gonna get my OEM ready. Let me see. Start up. Follow need to be a list. Push 96.
So Patrick, you might have to alter the system and just change the size.
But the database is down.
You start a month and see.
Okay. You can start up a database using the P5, and then you create SP5 on P5. Then you do what? Then you adjust the size now. It won't help anything.
Thank you, Bello.
You're welcome.
Do you know that what you did is very dangerous? Because you don't even know which P5 was used. Let's assume you are in an environment and the P5 was 1 year old or 2 years old. And that P5 the SP5 was modified. The database went through some changes. And you just issue create SP5 from P5. You just go and pick the old parameter file and the database start using it. That is very, very dangerous. So before you create an SP5 from a P5, make sure you open that P5 and you saw everything that's on it before you use it. Okay, so you're doing it in the school here, but never get to an environment and just issue this command without checking the P5 before, okay, prior to that. Just want to emphasize that.
All right, thank you. Equal SP5. Okay, I'll do the same thing with this one. Scope equal SP5. Okay, short. Okay, start. Great. SP5. So now I want to check the memory size and see if the change took effect. Okay. So now the memory target has a value. Let me check the other one. Same thing here. So now the second part will be on OEM. Let me see.
What's up, bro?
Exit. Okay. MCGM. Start to so. Okay. So when we log on to OEM, we go to database. I don't know why it's down. I don't know what's going on. Database is up.
But it's try to go to startup and the OEM.
You say startup?
Yeah, it's got, yeah, try to do this one. Yeah, I think he asked you the username and password.
But the database that you are using, you used first, it was Politic. Here is not the same name. It's
No,
Pochi.
it was the same thing. It was Portier. It's the same thing. I used it earlier. I don't know why it's doing that. Let's see. Just click. I don't understand why it says it's wrong username, wrong operator.
Isn't that Oracle?
Over here.
Yeah, of there, I think it's your Oracle.
And which password?
Your password, the Oracle password.
Class 26.
You still have class 26.
Okay, how about?
Yeah, I think it's of the you can put is 6 DBA. You put 6 and the BondTech one. I think.
So system here, right?
No,
Yeah,
if
you
you're going to
put
connect as
system.
6 GBA, it has to be 6.
6.
If you want to use system, you need to change the
Change the
package there.
yeah.
But it won't change.
And Mr. Apache, I think all this one is not helping. Just connect to the database and make sure it's open. Then you refresh.
It is open. It's listening.
Just connect back and make sure it's open.
Make sure go ahead and check the status because I think the
Yes.
database open. Put the statute too. Instance names,
Okay.
comma, statues.
Okay. I guess
All
Claire
should be BondTech 1, right?
BondTech 1.
Yeah.
And the Oracle, and then I think that should be the password, like when you log into. I don't know if
Right.
you changed it.
Yeah, I
If you change your
got it
password.
right. Yeah.
Okay.
Let me make sure it. Yeah. Yes. There you go. Thank you. All right. So when it's log on, you go to server and then memory advisor. So AMMM is enabled. You can see the advisor, the maximum value. So we can change the value. This is total memory. Again, as we saw on the slides, if you decide to change the maximum value, you have to restart the database. ASMM over here is enabled. So let me try to disable this. Okay, it's disabled. Now AMM is still enabled. I can either disable or change the value.
Je veux dire, l'actuel peut-être parce qu'il n'a.
So I disable ASMM. So I can decide to change the value of each memory component, either share pool, buffer cache, and this is how you can change it using OEM and using SQL as well. And with that, that's the end of my presentation. And I thank you for your patience. So I will hand over to the next speaker, which is Mr. Jones. I think it's there.
Yeah, I'm right here, Mr. Patrick.
All right, we got it.
Thank you, Mr. John.
Thank you, everyone.
Thank you, Mr. Patrick.
Thank you, sir. So Mr. John going to talk about huge pages.
So Patrick, please, you want to control the slides for me?
Yes, please, I do. I will.
All right, good evening, class. My name is Jones, and my name is Jones, and I'll be talking about another tool used by Oracle to kind of manage its performance, and this tool is Huge Pages. Huge Pages, I would say that it's a tool that is used at the level of it's a tool that is used at the level of the operating system. Now, before I dive into Huge Pages, I want to start by explaining pages. Pages is a page can be defined as a unit of storage which size is configured on an operating system. So we all know that storage is subdivided into two parts. Our storage is divided into disk and then another part as memory. The goal for every DBA is that most of your programs should be able to run on memory because, as we all know, memory is faster and you get quicker results. But normally, memory is very costly, and so we can't get everything run on the memory. So part of our storage is disk, and another part is memory. Now, the way the operating system, specifically for Linux, is configured is such that part of disk, because of the constant need of memory, and because Linux saw that they want to reduce swapping, part of disk is actually configured into memory. But this part of disk is configured as a kind of memory which is known as a virtual memory. So let's say we have our storage of 16 of let's say 32 gigabytes, and out of this 32, 18 is memory, and then the rest is disk. Linux is configured in such a way that we can gain extra memory from disk. But this extra memory that we gain from disk is considered as a virtual memory. Virtual memory is the sense that we use it, but once we are not running, this consumes it back. Now, this part of memory, this part of storage, which is memory, is not just, let's say we have a memory of, we have a memory of, let's say, 16G. All this part of memory is subdivided into little pieces, into frames, into other sub-units, which is known as pages. So our 16 gigabytes of memory is subdivided into smaller units, known as pages. These pages can be configured in probably 2 Ms or 2 kilobytes, or it depends. Now we know that the default size that Linux uses to define these pages is a 2 megabytes. Now, how does Huge Pages comes into play? Once Huge Pages is configured in our operating system, what happens is that Huge Pages, once the future Huge Pages is enabled in our operating system, what happens is that Huge Pages has the ability of increasing the size of this unit or of these pages. Let's say we have our pages are divided into subunits of probably 2 megabytes, and we know that we are running our SGA needs more space. It needs to constantly use, like, it gives a lot of work on the SGA. It gives a lot of work on the operating system, because what happens is it needs to use the 2 megabytes. Let's say you are running a program that probably needs 8 megabytes. You need to first of all use the 2 megabytes and then go use another 2, it moves you to 4, and then go to 6, and just like that until you get your whole 8 megabytes. So once we enable the future Huge Pages on the database, what happens is that it automatically booms up the amount of memory in these pages. So these pages moves probably from 2 megabytes to probably 32 or even 1 gigabyte. As such, you put in a whole program, and once you run it, it picks directly without having needing to swap from one unit to another. So I'll just go ahead and try so we understand the importance of Huge Pages. In Linux 2.6 kernel, features simply utilize huge pages to reduce virtual memory operations when working with lots of memory. What we are saying here is that when you need more memory, instead of Oracle needing to swap memory between memory and the disk, what happens is if you have actually enabled your huge page and gain some more space in this swapping doesn't take place because the swapping is costly. It takes some time and take a lot of resources. But if you actually gain more memory in terms of virtual memory from this, you can easily move programs from, if you need a memory and it's not in memory, Oracle first goes and gets this memory from your virtual memory that was configured from disk, rather than it getting directly into disk, which is more costly. Now, I also want to say that if you run Oracle database on Linux server with probably 16 gigabytes physical memory and your system global area is greater than 18 gigabytes, it is important that you should configure huge pages because huge pages helps to improve performance. One thing it is important for us to take note is that huge pages, the future huge pages, if huge pages, it doesn't run vis-a-vis with AMM. So if you have to configure, if you have to enable huge pages, then you must disable your AMM. I think that is it when it comes to the literature for huge pages. We might want to look at having some practicals done on it, but it's a little bit complicated. So we'll give the floor to our other speakers to talk on petitioning, and then if we have more time, then we talk on how huge pages can be enabled on Oracle 11G. Thank you.
Thank you, Mr. John.
Thank you, sir.
That was good. Thank you, man.
Thank you, Jones. So to talk about partitions, we'll have Fali and Devon. Fali will do the practical part of it, and Devon will do the theory part of it. Take it away, guys.
Hi, good evening, class. My name is Devon, and I'll be attempting to explain what I understand by partitioning. So what is partition? So general definition of a partition is basically breaking up anything into smaller pieces. And there are a lot of reasons for doing that. But in Oracle, partition is breaking a table into smaller pieces for better manageability and to enhance performance and availability for data in a particular table. So, for example, if you have like a table like with 1,000 rows and you're trying to access at least 10 of those rows, instead of using a lot of resources, searching the old table, you can create a partition just for those 10 rows that you're trying to retrieve the data from. In that way, you can get your result faster, and you can also save resources in the meanwhile, instead of just accessing the old table. So partition, like my other colleagues have said, it's a way of helping to perform the performance of the database. And there are different types of partition. There's the hash partition, there's the list partition, the range partition, and we have the composite partition, and also we have the interval partition. So hash partition, Oracle determines, in hash partition, Oracle determines how to organize the data in the table, and specified all the column you want to, which column you want to access on that table. So in hashing, in the hash partition, Oracle have created the algorithm that's called hashing algorithm. What that algorithm does, it ensures that your data is distributed on those partitions. So, and that algorithm is something that you cannot change. That's what Oracle have put in place so that you can, so that those data can be distributed equally and in the same size. For list partition, one second. The list partition is based on a list of partition. So instead of querying the whole table, you can just query the list. And unlike range and hash partition, multiple column partition keys are not supported for list partition. But if a table is partitioned by list, the partition key can only consist of a single column on that table. Can we go to the next slide, please? So range partition. So range partition is based on the range partition is based on the either a range of values numerically or alphabetically, ranging in how you want it to be, if it's from either you know, ascending or descending, you know, if it's from a higher number to a lower number. You can not just partition by numbers, you can do you know, alphabetically. So for example, if you're doing the years, like how we put you know, the number for the month and then the year, we can do January instead of, you know, 01, and then we can do a combination of either numerical and alphabetical together, and then you can, you know, choose how you want that data to be ranged as to, you know, from either a higher value to a lower value, or how you want it to be partitioned. Composite partition, on the other hand, is a mixture of any partitions. So you can partition either a range partition with a range partition. You can partition a range with a interval partition. So it's basically a combination of any two partitions that you can put together to you know, issue a query to retrieve data, which would have you get your information or your query faster. Advantages of partition, as you can see on the slide now. If someone needs to query and look for a particular record, the optimizer will redirect the server process to that particular partition. So if there's no partition and, you know, a query is issued, we know that the optimizer may go to the cache results, and then if the information is not there, then they'll have to, you know, go through the normal process of parsing and all that stuff. But if there is a partition created for that particular query that you're trying to retrieve, the optimizer will go directly to that partition, which will save you time and resources and give you the result right away. So that's one of the advantages of it. So we'll have Fali to do the practical and get a little bit more insight as to how the partition actually works. Thank you.
Thank you, Mr. Devin. I think you do the good job. Thank you so much. My name is Ifali Iya. I'm from Bafo team. One of the best group and the class 26. I'll go do the practice for the partition. I think Devin, because we don't have time, I don't want to just go tapping. I got some script I prepare for this practice. I go just copy and paste. I go just try to explain just a little bit what I'm going to do it. Thank you. Here, I got some script here for the range partition. What is work? I think I'll go paste. I go use the developer. I think that's what is good for this one.
Paste.
I go in the beginning. I think the partition, we got one table is not partition and table is partition. We can take the table not partition, we bring down to the partition, and we can create the table, we make the partition. That's what I go do now for the demonstration. I go just create the table and they make this on the partition. Here I got my table name. I go call my table name cell one. I go give it the column like the customer ID. I go give it the column like the order date. I go give it the column like the order month and the region. Here I go do the range partition. I put here the command is range by partition by range. I go do this partition for the order and the score date. Here I go break down the partition for the date. I go bring this one for the date, the date, month, and the year. Here is a partition. Here I give it the name. You can give it any name if you want any name. You want to give it a name like a P15 because I work it to the here 2015. I go give it 07 like the month. Here we got values less than. All of values is going to be for this, go feel party for this partition is going to be otherwise values less than 07 2017. That's mean like all of them says all of them value we go update of the for this less this date is going to be party for that one. That's so on. I go give you the demonstration right now. I think I forget the last one is mean like all of values go be. I go give you the example. We'll put the value for the month the month 6 June. It's gonna be for this partition. For the July, it will be for this partition. For August for this partition. For September for this partition. For October for this partition. For November for this partition. All of them updates go be like for this December is go be for it go be and this partition where that's where we put the maximum values. I'm so sorry. I didn't give you my secret developer. Just okay. I think when we see here, we go see say the table is create. We go try to put to share the data inside the table. When I go try to insert the data for the inside this table, the cell one, I go try to insert the data for 12 January 2015. That's what it's a one row headed. We go commit. Let's create. I think this data we share is going to be for this partition, the first partition. Go try to insert a couple that of there. Wait. we go try to see the select all from this table. That's give us the information we got inside this table, and we go try to see, for example, which information go to the partition 07. We go see here the partition. This information go to the 07. When you go see is Janeiro. That's why is less than this 0 and July 01. If you go try to see maybe and 9. You go see the information go to partition 9 is less than that day the 001 September. That's for the partition, the range partition. If you wanna, you can just see. I think that's it for the range partition. I go just see because now we don't have time. I go just see, do maybe one more, and I think the list partition is almost like the range partition. I go maybe go to the range partition to show you guys what is work. I think here we got hash partition. The same thing. We got when we got here the range partition. The range partition we got, I'll go give you the same name, the cells here, go put maybe 3. We got column customer ID. We got this column here. We see when we finish to create the column, we put the parentheses, we create the partition by the range. The range is the Oracle go choose the way go do the partition for this kind of this partition, but it's go be the key, is go be the customer ID, like Mr. Devan said before me. I think here we go put this table for 4 partition. We go call this partition the name. You could give it any name you want. That's here I prefer give you the C1, C2, C3, C4. We create a table and now we go try to insert a couple data inside.
We have 5 minutes left, Fali. That's to let you know.
Okay, I'll go. Maybe this one, the last one. I'll go just select. We'll see the data we got inside of there. I think we got 5 rows. Well, now we go see. We say for the hash partition, the Oracle go do the partition. Well, now we go check. We go check to see the way the Oracle do the partition, because here we don't know if Oracle give you some C1 or C2, C3, C4. We go check one now to see which one Oracle, the way Oracle did the work for us. I think it's not partition for this is C1. Thank you. Oh, no. I'm so sorry, guys. My bad. I think this is C3. I think C2 is not of the inside. And we go check the C1 because the name for the table was wrong. That's why it was giving us this error. And the C2, C1, 2 is not of there. We go check the C3. I think in the C3, Oracle give you the 2 rows for the C3 partition. I think they remain the whole, maybe the Oracle go give you that one to C4 partition. Okay, exactly. Oracle give you this 3 row left for the C partition. I thank you guys. I'm so sorry for we don't have time. If we got time, I cannot do all of demonstration for the partition, like the composite is amazing composite and the interval. For me, the best one is the interval because the Oracle create the partition himself. That's what. But I'm so sorry for the time. Thank you for your question.
Thank you, Fali.
Thank you, Fali.
All right. So class, I'll just summarize on our presentation. Our presentation was focused on 4 different tools used to enhance performance in Oracle. And these different tools affect Oracle performance at different levels. We looked at materialized view, which affects performance at the level of the application. We look at AMM and ASMM, which affects performance at the level of instance and application. We looked at huge pages, which affect performance at the level of system. And then we looked at partitioning, which affects performance at the level of application. So we're gonna open the floor for question, if Mr. Gaitan will let us.
Yes, hello? Say what, please?
I said we're gonna open the floor for questions.
Oh, sure, yes, let's take 5 minutes for questions. And in the meantime, is the other group ready while we take questions?
Yes, sir.
Yes, sir. Yes, sir. Okay. Yes, sir. So yes, let's take 5 minutes for questions. Then the other group can come at 7:10. Yeah, thanks.
So yeah, I have a question, please.
Yes, sir.
Okay, the first speaker made mention of materialized views, and it shows how data could be easily or faster be retrieved. So I don't know. He was unable to show me how faster data was being retrieved, and I just wanted to ask if who actually makes the decision? Is it the optimizer or how it really functions? How the materialized view really functions? Thank you.
Okay. I want to say that the idea about the materialized view affects performance, like I said, at the level of the application. It's not controlled by materialized view, like she explained. Materialized view is kind of a sub table, so it's not controlled by what you call it, the term you just used.
The optimizer?
By the optimizer. It's actually those working at the level of the developers. It's actually the developers or the DBA who notice that probably a table is so large and they want to reduce this table such that queries can run faster, and they make this decision based on what segment or what rows are easily being queried. What rows of the table are easily being queried. So they decide to develop a kind of a sub table from the main table.
I think John did a good explanation. Like if I go give you one example, if we got a table for the 1 million rows, the developer or the people working decide to say, okay, let's go create the materials view. We go calculate the table. We go create the materials view for make this table maybe for 6 columns or make this table for 10,000 rows. We calculate, we create the materials view, we create this one. One the user is going to query the data, is go to the materials view. If it's not have enough information, that's go pass the information for the master table. That's why if you query some information for the material view, it got 10,000 rows, it's going to be more fast than the one table have 1 million rows. That's why the main idea for just I cannot put something for what did you give explanation.
So,
Okay.
So when you issue your query, the optimizer kind of decide if it needs to start off this query right all from the beginning, or makes a decision if it can get the information from the materialized view.
I think the earlier explanation you gave was really important. It was more clarifying. Like you earlier said.
Okay.
Yeah. So is it safe to say? Okay, excuse me, please. Is it safe to say the main reason of creating a materialized view is for easy retrieval of data, or it's like just like to create a link to get a particular set of information, or like a particular set of information, like you don't want the user to access the entire table?
I will not say, we are not going to say which one is the main reason, but you decide in creating materialized view depending on the environment. For some environment, you might want to create it for easy retrieval of data. For other environment, you might want to create it because you don't want other users to view the information of other users. For example, the example that the presenter made about HR. Let's say we work in an environment and then HR has the whole information that contains people's salary, their names, and their vehicle types and things like that. And probably security wants to know the information related, a particular part of information that relates just to people and their tag numbers. You don't want to give them all that information because they will be viewing people's salary, which is not their business. So you kind of create a materialized view from the main table, and your materialized view table at that point in time is going to contain just the rows that they need to see. So we see that it depends on, there is no best reason why we create it, but it depends on the environment and what need you want to serve.
Good job, John.
Exactly. That's the good explanation, because when I was looking for materialized view, I saw for 3 people talk for the 3 different companies. It gives you the 3 different reasons to create the materialized view. That's why John said it depends on the environment. Thank you, John, for this good explanation.
Thank you, sir.
All right. Anyway, I'm pleased with the response. Thank you, man.
Okay, let's take one more question. If you have one more question.
Okay, I have a question.
Okay.
The person doing huge pages mentioned the fact that you have to configure huge pages, you must disable AMM. I want to know if it is obligatory, and if yes, why?
I will say that from the research, probably Gaetan will help us on it, but from the research, it shows that huge pages, the future huge pages cannot be enabled at the same time with AMM on Oracle from Oracle 11G upward. We didn't catch like the main reason why. Probably Gaetan want to help us on that. But it shows that they are not compatible. So if you want to enable one, then you need to disable the other. But we didn't kind of get any reason why both is.
Yes, you guys should know something. I think if you just want to use some logic, okay? If you are a product owner, you own a product, and you decide to release a feature, that feature, for any reason the feature doesn't work, what do? You turn down that feature, you move forward, you move on with some other features. So it comes to the level of development. So when developers are making, they are working on project, they are working on their project integration or whatever they are doing, they try things. Now, what happens is they will try use pages with AMM or whatever. They see that, okay, whenever they're using maybe AMM, they are having a lot of issues, a lot of bugs. And instead of staying on it for a long time, they can just turn it down if that feature can work better with something else. And that is valid for a lot of in Oracle, a lot of product in Oracle company. They have a lot of product like that can work with any platform, with some platform, or cannot work with some, some version of databases. So that is how it is. So the product owner is the one at the end of the day to turn down some features and to say, okay, this feature doesn't work best, doesn't work with AMM. So let's just adopt it. Let's just make it work with ASMM. If you ask me the reason behind it, I will not tell you because I'm not the person who released the feature. So that is what I just want to emphasize about it. I don't know any other reason behind, but I know I'm working in Oracle. There are a lot of features we turn down. But because, for instance, let's assume that they're having to release a feature in the cloud for a customer, and we notice that a lot of customers are having issues with that new feature that just came out. And we, the engineer, we are always struggling to fix the same issue. Every day, I can find myself, for instance, with 25 tickets, 50 tickets, 30 tickets. And developer will try their best to fix the issue. If at some point we see that we can find another alternative, we can just turn down the feature and move on to something else. That is how it works. So that is the same scenario. The same thing happened with use pages. Okay, so if someone asks you that, I don't know any other reason behind, but I know that is how Oracle or any other company work when it comes to releasing products. Okay.
Okay.
Yeah. Okay.
Please, Gaita, have a last question, please.
Last question. Yeah.
So, Pat mentioned that AMM will only be available on platforms that support dynamic release of memory. I do not really understand what is a platform that support. Just an example, if I can just have an example of that support the dynamic release of memory.
Okay, so there's a background noise here. So you see, you're asking them some question on dynamic what?
I repeat. The person doing AMM mentioned the fact that it must be available on platforms that support dynamic release of memory. Yeah. Okay. So I was just trying to know what are the platforms that support dynamic release of memory? Or if you could just, give an examples of those platforms that support.
There are some questions, right, that sometimes you can just be curious enough and just tap the keyboard. Okay? Yes. Some questions that yourself you can just tap the keyboard and figure out what it is. So first of all, I have to know which part of the presentation that we're talking about it. Okay? At some point I was involved in something else, but where, it depends on where they are talking about those dynamic whatever. AMM. Okay, which part of the PowerPoint?
AMM, yeah, Patrick Kefobia. I think it was the first one before the how AMM and ASM are related. The first one, just before that. Yeah. Available only on those platforms that support dynamic release of memory.
Okay. Just a platform where you can, dynamically change memory. Okay. And which platform work in any other Linux platform or Unix platform, Windows platform are dynamic release. So you have multiple other platforms where you can dynamically change memory. Okay, if that is what you want to understand about it. That's why I said, if you want to know the full list of all the platforms, you can Google, but I gave you a few of them. Okay, so whatever you know, all the Unix platform, it goes with IX, it goes with Linux Red Hat or Linux 6.7, all those platforms, and even associated with some kernels version, all those platforms support memory, dynamic memory. You can dynamically change, memory or increase or reduce memory on those platforms. So if there's a platform that doesn't support it, you can find it. I don't know a platform that doesn't support it because that's not my focus area. I never focus on that area. But I know some platforms that support it because maybe I've done it or I learned about it. Okay, so if you want to know more about it, all the platforms that are supported or not, you can definitely get, on your keyboard and Google and try to find out if there's any other platform apart from this. Okay. All right. Next group is okay. Sorry, we took some 5 minutes out of your time, so you can start now, please. The next group, yes, okay. Okay, thank you.
Good evening, class. My group and I today will be presenting on indexes, SQL profile, and SQL baseline. So it's just the outline of what we have to present to you guys. I'll begin with indexes, and practicals might come in along the line, but we have a lot of practicals though, but we'll see how we can manage it with time. Okay. Start with the very first slide. Indexes. What are indexes?
Excuse
Indexes
me,
are
Alex.
copies of selected columns of data from a table called database key or simply key. Can you guys hear me?
There's too much noise on your background, Alan.
Yeah, you got background
Hello?
noise.
Hello?
Alan,
Yeah,
you got a background.
we can hear you. There are a lot of noise in your background, sir.
1 minute, please. Hello, guys.
Yeah, we can hear you.
Oh, I'm so sorry for that. Okay, as I was saying, my group and I will be presenting on indexes, SQL profile, and SQL baseline. And I'm about to start with the SQL index, like the indexes, sorry. What are indexes? Many a times we've heard about the word indexes, but I'll really go to explain to us what indexes are really. Okay, practicals will come in as we move on. Okay. Indexes are copies of selected columns of data from a table called a database key or simply key, used to quickly locate data without the need to scan all the table's data. Indexes can be created using one or more columns or a database table, providing the basis for both rapid random lookup and efficient access of other records. Although Oracle allowed an unlimited number of indexes on a table, the indexes only help if they are used to speed up queries. So indexes are kind of database objects that we use to make the queries faster. We know our optimum goal in the database is to retrieve our data faster. The faster we can retrieve our data, the more efficient our databases or our work is. So indexes kind of reduce the time and makes data retrieval faster. So okay. So how can this kind of explain the importance of an index? An index is very critical to query performance, but too many indexes can actually harm the performance of insert and update queries because this requires arrangement of indexes which can be time consuming based on the size of the table or number of rows of records on the table. Always create indexes on columns that are frequently used in a select query because there is a huge performance difference between an indexed and non-indexed column in SQL queries. Though you should be careful with creating too many indexes because they will make the update and delete statements slow. This is easy as it says, like if you have a big table and you create an index on that table, when you insert data or you update data on that particular table, it will be a mandatory something to go to the index and change and also update the index or rebuild the index to match that table, since there was an update and an insert statement. But when we do, like, for a table, take example, a table that allows only select statements to be run on it. Those tables, no matter how they grow or if they have large sizes, if you keep selecting and you don't update or insert on those tables, there is no need for change of index because nothing has changed on that table. There is no need for change of index. Okay. I'll move on to explain the index architecture. We have cluster index and we have non-cluster index. I'll start with the cluster index. A cluster index determines the physical storing order of rows in a table. One thing to remember about cluster index is that it organizes data in clusters, which help to quickly scan and retrieve data in a range. They are stored, cluster index are stored on the same table, and we can only have one cluster index per table. This sequel down here, it just shows us how we can create a cluster index. Here is the index name and the table name on which you're creating the cluster index and the column on which the cluster index is created. But by default, if there is a primary key column on the table, when you create that table with that primary key column, by default, Oracle will create a cluster index on that primary key column. And what it says here that data is arranged in a table based on the cluster table, it means that when you create that table and that index, that cluster index is created on that primary key column, just take, for example, the primary key column is the ID, or let's say customer ID. Let's say it ranges from 1 to 10. And you create that table, you're about to feed in data into that table. And just, for example, just say you start by fitting the ID number 10, and then you move on to 2, then you later go to 5. You do it randomly. When you do that, this data is being fed into that table according to the cluster index that is created on that customer ID column. So it will rearrange it in order. Despite the fact that you put it randomly, you put 10 before 1, by the time you insert 1, 1 will come before 10 and so on, and that is how it goes down. And you bear with me that you cannot have 2 of such indexes on the same table. Just imagine one is arranging based on column ID and based on employee ID, and another one is arranging based on first name. There is no way, and you say, okay, let my first name come in alphabetical order. Take, for example, somebody with the first name Z, but he's number 1. There is no way Z is going to come before, go right down, since the row ID is, the customer ID is 1. So that is why you cannot have 2 cluster indexes on the same table. For example, just look at this structure here. Here you have the root node, and here you have the branch node, and here you have the leaf node. So here, this is at the leaf node, this is actually where the data is, at the level of the leaf node. But we will see on the other one, you will see the difference between the cluster and the non-cluster index. Okay, now the non-cluster index. It's a non-cluster index uses a pointer which points to cluster index. That is why in index tree, in case of cluster index, leaf contains data, but in case of non-cluster index, it contains pointer. It contains pointer to the data. That pointers are points to the data. A non-cluster index allows you to add a unique key for a table. Non-cluster index are stored separately from the table, and we can have more than one of such indexes on the same table, just as I was explaining. For the non-cluster index, you can have a non-cluster index on the first name, you can still have it on the ID at the same time. This is explained because the non-cluster index is not stored on the same table. For example, it is stored on a different table. Meaning if you have 100 rows on a table and you create a non-cluster index, it will have its own table that has 100 rows. So it will have that column that contains the index, and it will have the row ID. So it works with the column that contains the index and the row ID. Reason why they say it has pointers is because let's just take a look at the diagram. This is the cluster index and this is the non-cluster index. Here you see that at the level of the leaf nodes, the actual data is there, for the cluster index. But for the non-cluster index, at the level of the leaf node, we have no data, we have pointers, and these pointers now point to the actual data. That's why we say, in case like we say, what is it? That's why we say to retrieve data using the non-cluster index, you have to point back to the cluster index to retrieve your data, because at the level of the leaf node in the cluster index, that is where the real data is. But if you check here on the non-cluster, it doesn't have any data at the level of the leaf node. And here we have the create statement for the non-cluster index. It's just almost the same like the cluster index, but you just specify non-cluster. Okay. With that said, we'll go to the types of indexes. Typically, the database retrieve table data by alternately reading an index block and then a table block. Oracle database supports several types of indexes. So we have normal, that is a normal or the B-tree index. We have the bitmap index, partition indexes, function-based indexes, and the domain indexes. We'll just define each and talk on each on the next slide. Okay, let's do the normal or B-tree index. By associating a key with a role or range of roles, B-tree provide excellent retrieval performance for a wide range of queries, including exact match and range searches. A B-tree index is balanced because all leaf blocks automatically stay at the same depth. Thus, retrieval of any record from anywhere in the index takes approximately the same amount of time. By default, Oracle database create B-tree indexes. A B-tree index has two types of blocks. You have the branch block that store minimum key prefix needed to make a branching decision between two keys. The branch blocks contain a pointer to the child block containing the key. It's just like, actually, it's a road leading to the data you really need, but that's why I say it has a pointer that points directly to the direction where you actually retrieve your data. Then you have the leaf block that contains every index data value and the corresponding row ID used to locate the actual rows. So if we want to create the normal or the B-tree index, this SQL statement down here, like it's just like the normal index creation. Yeah, the SQL is not different from when you want to create any normal index. That's why they said by default the database will create the B-tree index. Okay, I'll move to the next slide that talks about the bitmap indexes. A bitmap index is smaller than a B-tree. A bitmap index is smaller than a B-tree index because it stores only the row ID and a series of bits. A bitmap index is one that creates a two-dimensional map of rows and value in a specific column. Generally, bitmap indexes become useful when you have a whole bunch of them on different columns, so that they can all be used together to be more selective on roles that are otherwise you did need a full table scan. The size of the bitmap index depends on the cardinality of the columns on which it is created, as well as the data distribution. A bitmap index on a column will be smaller than a B-tree index on the same column. So the difference between the bitmap index and the B-tree index is that these indexes are created on particular rows. So they are created only on particular rows. For example, take a table you have, like, let's just take 50 rows, and each index is created on a row. Just imagine if you want to retrieve data from 10 rows and you have an index created just on one row, meaning there's no need for that index. You need to go through the full scan. But if you have, that's why they say they are useful only when they're in bunch, when they're created, when there are too many of them. So in other words, if we have to retrieve those 10 rows, as we said before, meaning we have to make sure that all of these 10 rows we are about to retrieve have these bitmap indexes created on them. And here we have the statement on how to create a bitmap index. It's almost the same like the B-tree, just that you specify bitmap index. So we'll move to the next slide where we have partition indexes. A partition index in Oracle 11J is simply an index broken into multiple pieces. By breaking an index into multiple physical pieces, you are accessing much smaller pieces faster, and you may separate the pieces onto different disk drives, reducing the input-output contention. Both B-tree and bitmap index can be partitioned. Partitioning adds many possibilities to help improve performance and increase maintainability. The main reason to partition the index is to reduce the size of the index that need to be read, and to enable placing the partition in separate table spaces to improve reliability and availability. So basically here, just imagine tables that have millions of rows. If you have a table that has millions of rows and you create an index on that table, logically that index will be a very big index tool. So breaking it down to various parts, just like our friends that spoke about partitioning tables, in as much as tables can be partitioned, index can be partitioned too. You can as well like to partition your tables before you create index on them. Or when you create large indexes, you have to partition them so that they fit those and so that they can be easily retrieved. Reason why we have to partition indexes too, so that when we issue a query, it should not be like a table should not be that much. An index should not be that much larger that the optimizer would think either than for me to use this table, I rather go a full scan, because when you look at the full scan and the index, there is no difference. So that is basically it about the partition index. And here we have the SQL statement to create a partition index. You can only create a partition index when you've partitioned your table. So I'll move to the next type of index, which is the function-based index. A function-based index allows you to match anywhere clause in a SQL statement and remove unnecessary large table full table scan with super fast index range scan. They enable you to construct queries that evaluate the value returned by an expression, which in turn may include built-in or use-defined functions. The SQL optimizer can estimate selectivity more accurately if the expressions are materialized in a function-based index. We'll be doing practicals, we'll see more about this. Okay, and then we'll move to the last type of the index, which is the domain indexes, which are domain indexes, sorry. A domain index is an extension to the Oracle index system that allows developers to create their own index type. A domain index can only be placed on a single column in Oracle. Multiple domain indexes can be created on the same column if their index types are different. The domain index is used for indexing non-traditional data such as LOB data, video data, and other non-textual columns. So this is basically the kind of indexes that, for example, if you have our data and part of the data are large objects and or videos, we need this kind of domain, this kind of index, which is a domain index, in order to retrieve and access them quickly. It's not like a DBA cannot use the domain index. They do use them because it comes a time when we automatically have large objects and maybe we store videos too, keep videos. So we will definitely use them, but people that use them more frequently are developers. So I'll move to some common parts, some common index access parts, some common ways in which index are retrieved. The part in which they're used to retrieve data. The first one will have an index full scan. We should not forget that data is also retrieved. Like the main way data is retrieved, if you don't use an index, is the table full scan, right? So if you don't use an index, the data always goes through the table full scan. And again, we have the role ID. We know on every table, not necessarily every table, it's not mandatory that every table should have a primary key, but it is mandatory that it's not even like mandatory. Like when you create a table, automatically Oracle assigns row ID to every row on that table. So row ID is a principal way of retrieving data too, because like when you do full scan, it also goes through like row ID before the data is actually retrieved. So for the common index access part, we have the index full scan. After this slide, I'll be doing the practicals for this so that we really see the difference between these scans. And then I'll also show us how we create an index and how we create an index and so on. Yeah. So we'll go with the index full scan. The query has the query has order by, it has the order by and the group clause only on the index column. So if you want this to really show out, like you have to, your query should make sure that your query has the order by clause or the group by, sorry, I have just group here. It's supposed to be group by clause. Then you have the index fast full scan. The index contains all columns needed for the query. You have the index range scan, in which the where clause of a query here there is one or more columns with, like when you do your query and you use the where clause, you should have like one or more columns with the various sign, like the greater than, the equal to, this smaller than, between, and the percentage. Then you have the index unique scan. The column with the where clause is the primary key column or the unique key column. And here we make sure that we retrieve only one row ID from the table at a time. And we should also use the equality sign or the equality operator. And then you have the index join scan, which is used when the combination of multiple indexes store the column of a query. So I will just dash to put it where we'll just do some little practicals. So guys, okay. Okay, so here I would like us to know that when you create an index on a single row, it's known as a simple index. And you know, indexes can also be created on more than one row, and in that case we call them the composite indexes. So here I will just go by, so I'm creating an index on the HR.employee table, and I'm creating that index on the first name. So here it says index created. So I'll be demonstrating. I'll just want us to create both indexes at a blow. Like, let's just create the composite index too. So there we go. Index are created. So we'll now retrieve data from that same table to demonstrate the index full scan. So to demonstrate the index full scan, we'll go by this. So we'll have to set, let's set auto trace, so on. Okay, so we'll run this query now. Okay, so here we see our index full scan right here. The reason why this was an index full scan, let's go back to the SQL we ran. Let's go back to the SQL run. We selected first name from HR.employee, order by the last name. Remember, the definition says when you run your query and you use the clause order by, it will give you the index we use will be the index full scan. So we're going to go again with this one. We'll do now the index range scan. And remember, the definition says when we use when you run your query and your query contains less than, greater than, or a percentage sign, or between, that is when the index that you use will use the index range scan path. So we'll just go ahead and run this one since we still have our auto trace on. And run this one. Sorry, I don't think I copied it. It's like a mix up somewhere. You still have index full scan. Okay. Okay, we'll come back to the index range scan. Let's move forward. Let's do the unique scan. Let's do the unique scan. Remember the unique scan, it says we must, like the index which we are using must contain all the columns we are querying, and we must use the equal sign. So let's go ahead and do this one. Let's see. Okay, here we have our index unique scan. So it depending on how you frame your query, the index will take a they will take different parts based on how your query looks like. Let's just do the index fast full scan and okay. So here, remember the index fast full scan, that it also tells us that we need to use all the columns, that the columns we query, all the columns we query must be indexed for us to have the index fast full scan. Okay, I think with that done, we'll go back to our slides, and the next group member is going to continue from here, and she'll be doing profiles, SQL profiles. Thank you, guys. See you again when I come up.
Thank you.
Good evening, everybody. I'm Estelle, and I will continue with the SQL profile and the SQL baseline. So I'll start with the profile. I'll start by defining what is the SQL profile. The SQL profile is a collection of auxiliary statistics on a query, including all table and column referenced in the query. The profile is stored in the data dictionary. What I want to say first, before I continue, what I want to say is that both the SQL profile and the SQL baseline are nothing but collection and store hints that attach to their target SQLs. So it has more to do with the hints and the target SQL. So the hints and the plans that will be used to execute the SQL. So the profile is stored in the data dictionary. The optimizer use this information during optimization to determine the most optimal plan. Hints to the SQL query to give direction to the optimizer. So it gives hints to the SQL to the optimizer it gives hints so the optimizer can use it to give a better the optimizer can use it to have a better direction, to know where to go, what plans to use, what route to go to, what routes to use. Because when the user issue a query, when the user actually issue a query, that query needs to be profiled. So you will gather statistic in the data dictionary to know what kind of hints to give to the optimizer. The SQL profile are created when the DBA invoked the SQL tuning advisor. When significant variants are found, SQL tuning advisor bundle corrective action together in an SQL profile, then recommends its acceptance. The corrected statistic in the SQL profile can improve optimizer estimates, which in turn leads the optimizer to select a better plan. SQL profile is implemented using hints that address different types of problems. Sorry. When you implement a SQL profile, a database creator, when you implement the SQL profile, the database creates a profile and store it persistently in the data dictionary. So whenever a SQL profile is accepted or implemented is the same thing. Whenever it's implemented, the database will store it persistently in the data dictionary. Remember, we said earlier that the profile is stored in the data dictionary. However, the SQL profile information is not exposed through the regular dictionary view. So here is basically how to manage the SQL profile. You have all the 5 steps. You start with implementing the SQL profile. You can see at the same time I will be reading, you can see right here on the graph, you will see that you implement the SQL profile by using this procedure, dbms_SQL tune.accept_SQL profile. So implementing a SQL profile means storing it persistently in the database. A profile must be implemented before the optimizer can use it as an input when generating a plan. If the database recommends both an index and an SQL profile, then either use both or the SQL profile only. So the database will prefer to use the SQL profile than using the index.
How are you?
Good, how are you?
I'm good. Good.
If you create an index, then the optimizer may need the profile to pick the new index. To implement the SQL profile, execute the dbms_. So basically what I said earlier. And then you obtain information. After implementing, you have to obtain information about the SQL profile stored in the database. So after you did this, you come here. This is the next step. After this one, this is the next step. This is the list where you find the list of the SQL profiles or the list of the SQL profiles. You connect to the SQL Plus to the database with the appropriate privileges, and then you query the DBA_SQL_ profile view. The third step is optional. You modify the implement SQL profile. So it's this one. This is the third step right here. So you can choose to alter the SQL profile if you choose to, if you want to. And then after that, you can alter attribute of existing. Basically this, you can alter attribute of existing.
Please mute yourself, Ali.
You can alter attribute of existing SQL profile using the attribute name parameter of the alter_SQL_ profile procedure. To alter the SQL profile, you connect to SQL Plus to the database with the appropriate privileges and then use this command, the alter_SQL_ profile procedure, and set the attribute name. After you've done all of it, you can drop the profile if it's not longer needed. So drop the implemented SQL profile when it's no longer needed. You can drop the SQL profile using drop_SQL_ profile procedure. So before I go to the baseline, Alan will come back and do a little bit of practice.
Okay, guys, I'm back again, and this time around, talking on the SQL profile. we're going to do a little bit of practical just to run the SQL Tuning Advisor. We see how it works, how it advises on what profile to take, and how at the end of the day, the recommendation the database gives us based on that particular profile. So without wasting so much time, we'll skip into the practicals where the set auto off. Okay, guys, this is the declare statement for the SQL Tuning Advisor, and here we see here that this it uses the SQL ID. It uses the SQL ID. So we'll go and we'll run a SQL. We generate the SQL ID. We feed it here, and we'll move from there. So let's go back to here. Let me just run. Okay, let me see. Okay. Let's just run this last statement. Just see. Okay. Then now let's retrieve our SQL ID of the SQL statement we just ran. Retrieve our SQL ID. Okay, guys, here we have our SQL ID. Here's a SQL ID right here. I'm sorry for not setting the line size and whatever, but here is my, see, I selected SQL ID and the SQL text. Here's a SQL text, and this is our SQL ID. So copy the SQL ID and modify the declare statement. So here, replace this with our SQL ID, and wherever here to modify it with our SQL ID. This you can put anything here because it's a tax name, but most often I would just like to still replace it with the same SQL ID. Okay, so we'll go and run our declare statement. Okay, the statement is complete successfully. So the next step will be to execute our SQL tuning statement, like to really execute our SQL profile. And then after that, we're going to run this other statement to select that particular SQL profile. When we select it and run this as a recommendation from Dual, this is basically asking Oracle to give us a recommendation per this particular SQL profile that we are working on. So based on the recommendation that Oracle will give us, we'll decide to go to the next part of the exercise. Either we accept the profile because it gives you a recommendation like, okay, this is good, you can accept the profile. Now go to executing the accept this other SQL statement to accept the profile. But this other statement is only run depending on the result of the recommendation. Okay, so we'll have to change our tax name still. Remember, it's not the same tax as it is here, so make sure we edit it. Sorry. Okay. So run this. Successfully run. So una okay. So we'll now run the recommendation statement to see how it goes. Just see. Recommendation, it just says recommendation, general information section. There's no like recommendation for this particular SQL statement. So if we go ahead to issue this one, because this is accept, you cannot accept something that has not been recommended. So generally when it's recommended, there is a percentage there. It's like it tells you, Oracle, this particular SQL profile is at 90, or let me say like 97 or 98 or 99% recommended, meaning it's recommending this the optimizer to use that particular SQL profile. So if we have to run this order, I think I will just have this included in the materials that we're about to send to the group, so that it helps us if at all we have a result, a meaningful result at the end of the recommendation. So furthermore, we have once you accept your profile, and there's this other statement, this one, where you can still run this other statement to look for to check the profile name. Then once you have your profile name, you have it substitute down here to enable the profile or disable it. So the profile can be enabled or disabled. So this is the SQL statement to enable or disable your profile, your SQL profile. But to have this, you must need the SQL profile name. And which cannot have a SQL profile until you accept it and you implement it. That's when you can get a name. So here, this other one, here is how you can drop, is a SQL to drop the profile if you no longer need it. As Estelle earlier said, the last phrase of it is, if you don't need the SQL profile anymore, what do you do? So you drop it. So here you still make use of the name. Okay, with that said and done, she's going to come back and continue with SQL profile, SQL baseline, sorry. Thank you.
Okay, I'll continue with the SQL baseline. So the first part would be the SQL management base. So I'll start by defining what is the SQL baseline. The SQL baseline is a set of one or more accepted plan that contain hints, the plan hash value or other plan related data. Acceptable execution plan are moved from the SQL plan history into the SQL plan baseline, which is referred to as evolving plan. The database and history are maintained in the SQL management base, which is kept in the SIGSOX table space. Included in this SQL management baseline is also any related SQL profile for the statement. So in the baseline, you will have all the SQL profiles that were accepted, that were implemented. So now we'll go with the hints. Now we'll go with the hints. Before I talk about the hints, I just want to remind what is the optimizer hints. I just want to remind everybody what is the optimizer, because the group that presented before us, I think they talk about the optimizer. The optimizer actually generates, I want to make a little bit of reminder about the optimizer. I don't want to go deeply into it. The optimizer generates a set of potential plan for the SQL statement based on available access path and hints. The optimizer estimates the cost of each plan based on statistic in the data dictionary. Statistic includes information of the data distribution and storage characteristic of the tables, indexes, and partition accessed by the statement. So here in the optimizer hint, what do we have? We said that an Oracle hint is an optimizer directive that is embedded into the SQL statement to suggest to Oracle how the statement should be executed. So basically is there to make some suggestion to tell you, okay, you should be doing this, to tell Oracle you should be doing this or be doing that. Depends on the hints that it has. The Oracle index hints instruct the optimizer to use an index scan for the specified table. Oracle hints such as order, leading, index, full can be tamed a while optimizer and give you optimal performance. Hints apply only to the optimization of the block of a statement in which they appear. Each of the following hints instructs the optimizer to use a specific access path for a table. So a hint is like, optimizer hint is like, okay, how am I going to explain it to you? It's much easier. It's just like when you're trying to go somewhere and I will tell you that, oh, there was an accident on that, on that road. Don't take that road because, you'll be stuck over there. That's a hint I'm giving you. So for you to know that, okay, you should be choosing another route. You should be taking another road to get to wherever you are going to. So here we have full cluster, hash, index, no index, index ascendant, index combine, index join, index descendant, index FFS, no index FFS, index XX, index SS ascendant, is index SS descendant, no index SS. Specifying one of these hints causes the optimizer to choose the specified access path only if the access path is available based on the existence of an index or cluster and on the syntactic construct of the SQL statement. If a hint specifies an unavailable access plan, then the optimizer ignores it. Okay, I will skip to the capturing and evolving SQL baseline. So you have two ways to populate the SQL baseline, by capturing and evolving. Capturing the initial loads of the plan into the baseline. Evolving is the evaluation of the new plans into the SQL history to ensure that they will not cause the statement to regress and then add. So basically what do you have? After the profile was implemented, you have the optimizer, and then you have this part, you have the base. In the base, you have, what do you have? You have the history and you have the baseline. The history has couple of pan that you will keep for it not to regress, not to be flushed out. You will keep them. So whenever the optimizer will say, okay, the optimizer will use the hints and say, you can use this route or you use that other route. If the route has already existed in the base in the history, it will not create the new thing. If the thing already existed, so it will just push the thing into the baseline for the thing for the plan to be executed by that plan, for the SQL to be executed by that plan. There are two ways to initiate the captures, automatically or manually. To do an automatic load, change the optimizer underscore capture underscore SQL plan and its default of false. So usually in the database, the default is false, so you have to set it to true. During automatic capture, the first plan generated of any statement is flagged as accepted and placed into both the SQL history and the SQL baseline. So once the plan is accepted, is implemented, what is happening, it will be both into the history and the baseline. Any subsequent execution plan are placed only into the history. Manual loading of the initial SQL baseline is accomplished by using the DBMS SPM package supplied with Oracle. There are two functions that load the SQL plan. These are load plan from the SQL set and load plan from the cursor cache. Any plan that are manually loaded are placed into the SQL baseline. So basically, whenever you do it manually, when you do it automatically, it will be into the history. If it will check if it's accepted, and then it will go into the history before it goes into the baseline. But when you do it manually, it's accepted immediately, because it's kind of you forcing it to be the plan accepted. You forced to be, you decide that I will use this one. So that's the plan that they will be using. So a little bit of practice about that before I come back to finish it.
Okay, guys, I'm back for another series of practicals. Here I will be manually loading the SQL statement into our SQL baseline. So without taking much of your time, let's go. Let's see how it works. Okay, for that to work, we'll need to do the SQL ID too. We need to retrieve the SQL ID, and for the baseline, the SQL that they identify by the SQL ID, but for the SQL profile, sorry, the SQL statements are identified by SQL ID, but for the baseline, they are identified by the plan hash value. So that's why we're going to query the SQL ID and the plan hash value, because we need both of them to use in the declare statement for our SQL baseline. So I would like us to run a query, and from there, so here run that SQL statement, then we're going to determine the ID of that SQL statement and the hash plan value. So where and then do this. Oh, what's going on? Never selected. Let's add value. 1 second. Okay, guys, we'll have a series of statements here, and if you have something, exactly what this thing is saying. Okay, let me take out this like that equal to this. Okay, here we have the SQL ID and the plan hash value for that particular statement. So I'm gonna copy this, the SQL ID first. Let's start with the SQL ID. And we insert the SQL ID here where it says SQL ID. Actually, and then we do the plan hash value. Here's our plan hash value. So I have it inserted here where it says our plan hash value. Okay, those are just the two things we insert on this plan. And then we'll run the declare statement. Go. Okay. Successfully completed. So here we're actually forcing the plan into the baseline. Now, to force the plan to the baseline, sorry. Let me correct something I said that wasn't correct. I said in the SQL profile, right? The SQL statement identified by the SQL ID, but in the SQL baseline, they're not identified by the hash plan value because each SQL statement has a hash plan value. So they're identified by the SQL handle. Sorry, that's a correction, please. The SQL handle. So here we're going to select the SQL handle of that particular query that we ran, because we need the SQL handle in order to the SQL handle value. We need it in order to see if our plan has been accepted into the baseline or not. So copy that and we'll paste it right here. Okay, this is our SQL handle right here. So copy our SQL handle and we have it replaced in here. Where is his SQL handle? Place it in there and we run the select statement. This is to find out if our plan has been accepted into the baseline. So here we go. And this is what we have. So this is just telling us everything that we've run, like the SQL handle is here, the SQL text, this is the SQL text we ran, and the plan name, this is the plan name. Since remember when we did the SQL plan the other way, we didn't have the plan name because the recommendation, it didn't tell us if we should accept it or not. So that's the reason why we didn't have a name. But here we have a name and it is enabled. It is not fixed because it is not fixed because the optimizer must not use it. So it's not something that is there. Then we have accepted, meaning it has been accepted into the baseline. Then we have how was it done? It was done manually. This is the origin. So guys, this is just telling us that our plan has been accepted into the baseline. So I would then hand over to Esther for her to do the conclusion. Thank you.
Okay, thank you, Alan. So basically, he was just showing us how to manually load the plan into the baseline. So you saw, you heard he was talking about the fixed plan, and the one that we just run, the plan was not fixed. So we have a little chart, but we did not include that chart into the into our slides. Basically, that chart is about, it talks about when the plan is enabled, accepted, fixed. So we would post it into the WhatsApp, with the Word document that we have, and you guys will see everything. So it says everything when the plan is accepted or not, is enabled or not, fixed or not. So you will see everything about that. But before I continue, I just want to say this. A SQL plan baseline can be used or selected by the optimizer. The SQL optimizer must be initialized with at least one accepted plan for the repeatable statements being run. So, okay, right here, we have the SQL management base. So you see actually how the structure of the management base is with the history, the SQL plan history and the SQL plan baseline. So the SQL plan baseline is where the accepted plan for that SQL, for that query are located. And in the history, you have all the plans for, all the queries that has, that have been queried on that database. So it says, if the optimizer generates a new plan for a repeated SQL statement, it is automatically added to the SQL plan history. However, it is not automatically added to the SQL baseline. So for it to be added to a SQL plan baseline, it has to do with the query. It has to do with the query. So if the plan that are in the history has nothing to do with the query, it will not be in the baseline for as accepted plan. So the optimizer will basically check for it. Okay, it will check for the query that is issued, and it will look for the the possible plan execution plans, and it will look the one that is the one that is better for actually to run, to execute it, and it will push it into the baseline. So it will move from the history to the baseline, and from the baseline it will be executed, based on the plan that it will choose. It must be evolved or verified first. So each plan that is pushing to the baseline are verified. They are not just pushing to the baseline just like that. They are verified first. So it depends on, you might query something today. Just let's say you go into the store. You have the same route that you're taking every day. But one day something might happen and you decide to change the route. That's exactly how it works. So just think of it that way. The automatic SQL tuning job that is run with automatically verified plan that have been added into the SQL plan history. Verification simply means that the plan are checked to ensure that the new plan would not result into a performance degradation or regression. So those plans, we don't want them to be out of the history, we don't want them to be out of the history. So you might have the plan 1 and 2 in the baseline, and somebody else come and query something different, and the plan 3 works for that query. It doesn't mean that plan 1 and 2 will be flushed out completely from the management base. It will stay in the history, for maybe the next time that somebody will come and query something that is similar, so you can use the plan, either 1 or 2. Manually running the SQL tuning advisor may result in plan being added to the SQL plan baseline. The alter SQL plan baseline function of the DBMS SPM can be used to change the status of the plan in the SQL history to accepted. By default, the SQL management base is limited to no more than 10% of the 6-house table space. This can be adjusted by using the DBMS SPM, the configure, space in bracket, you have space budget %, and this is the number. so you can use that comment. Any plan that is not used, that has not been used in 53 weeks will automatically be purged. So this is also adjustable value, and it's changed with this comment, this other comment, this procedure, DBMS_SPM configure procedure. In addition, plan can be manually removed from the SBM using this other function, DBMS SPM.drop SQL plan baseline. So right here, we have like a chart of what is actually happening from where, from when the user actually issued the SQL statement. So when the SQL statement is issued by the user, you see you have 1, 2, 3. So follow with me, please. It's issued by the user. The statement goes through the parsing. So right here, you have the parsing. And for the parsing, from the parsing, it will go, it checks all of this. And from the parsing, it will go to the share pool. That means that the share SQL area already contains the result for the SQL statement, after which the SQL statement can be returned to the user since the result is already in the library cache. On the other hand, if the parsing is a hard parsing, then the optimizer comes and generates a code which then leads to the execution of the SQL statement before it goes back, it goes back to the share pool and the user. So here we have our last slide, and it's about, we just wanted to show how how profile and baseline used to influence the SQL execution plan. The SQL profile are mostly advisors that work with the optimizer, making its estimation more precise. SPM baseline, on the other hand, are enforced. They completely ignore the optimizer and simply tell the runtime engine what to do. The difference between the plan baseline and the SQL profile, both baseline and profile are internally implemented using the hints. In general, SQL baseline are proactive, whereas SQL profile are reactive. When SQL plan baseline prevent the optimizer from using suboptimal plans in the future. The database creates SQL profile when you invoke the SQL tuning advisor. Because the SQL profile mechanism is reactive, it cannot guarantee stable performance as drastic database changes occur. So that's about it for us. Thank you for listening.
Thanks so much. Very good.
Thank you.
Good job, Alain.
Thank you.
It wasn't easy.
Okay, please, I have a question for you guys.
Yes, boss.
Okay, hello?
Yep.
Okay, you guys made mention of SQL profile and SQL hints, right? And based on external explanation, it shows that they both influence optimizer to probably execute a SQL statement. So I don't know, can I get a difference? Because I really couldn't get the difference between SQL profile and hints.
Okay. I would say something like, and then maybe Esther will have something to say, but from my understanding, SQL profile, the SQL profile, what it does is gather statistics. If it goes it gathers statistics and it's like, okay, I think this statistics is going to help the optimizer to make a better decision in executing a SQL statement. So that is basically what the SQL profile does. You try to gather those statistics and say, hey, optimizer, here's what can help you. On the other hand, the hint says, okay, optimizer, you have choose this path to take. Oh, sorry, there is something on the way. Please, can you change your route? That is just the difference between the SQL profile and the hint. Thank you. Did I answer your question?
Yeah, you said. Okay, Alan.
Yes, sir.
I appreciate your response, but based on what based on my search, I might be wrong, but based on what I know about hint, it's like it also guide optimizer to choose the best execution plan. I understand why you said maybe it could give the best possible plan. You understand?
Let me correct something. It guides it to take the best execution plan. A plan is not an execution plan until it is being executed, like until the optimizer uses that plan completely. Until he uses it completely. If not, it will just be a plan, like a normal plan.
Okay,
so
let me say. Okay, let me just take that back. Let me say it give a best execution path, or let me say give like let me just say like a path to execute the SQL statement.
The hint?
Yes.
Oh, like I said before, the optimizer has already determined on what plan to take. Normally, that plan, the optimizer is taking that plan. It's not guaranteed that that plan will be the execution plan. Something may happen on the way. What the hint does is just that, okay, since it can determine those stops that will stop the optimizer on the way and say, oh, optimizer, here you come in, there is something on your way. Can you change your route? That is the work of the hint. On the other hand, the SQL profile does gather just statistics from the very beginning and say, oh, optimizer, this can help you reach your goal. You understand the difference?
Yeah, I got it.
Okay, thank you.
Esther, can you pull up slide 22, please?
Which one?
Slide 22.
Oh, okay.
So you said when the SQL statement is issued, so it goes to the parsing first. So it does all the 3 checks and then get to the share pool. So in the share pool, it gets into the SQL share SQL area to see if they were an existing SQL, right?
Yes, sir.
So if it finds it, if there were an existing SQL, and then you return the result to the user.
Yes, sir.
So it goes to the SQL share area first before it goes to library cache, or what's the order?
The order is it goes through the library cache first before it goes to the share SQL area.
Okay. Okay. Can you elaborate a little bit the role of the optimizer and the data dictionary at this level?
The optimizer and the data dictionary. I would say basically the data dictionary. What does the data dictionary contains? Metadata, right?
Metadata, yes.
Contains metadata. The optimizer needs every statistic necessary to take his route. So the relationship between the optimizer and the data dictionary here is the metadata it gets from the statistics it gets from the data dictionary, which is the metadata, and which can in any way help the optimizer to reach his route, like to reach his goal. Did I help?
Yeah, you help.
Okay, thank you.
Okay, another question. What's the code generator?
Like I said, the optimizer, like in order for the optimizer to use the route,
yeah,
it will generate a code, right?
Okay.
It will generate a code. Is the code that lead to the fetching of the data in the share pool.
Okay. All right.
Okay, Alan.
Yes, sir.
Okay, I have a question for Fali, because he presented partitioning. I don't know if he's listening.
For
Fali, he presented partitioning. If
Okay.
that's okay.
Sure.
Fali.
Yes, sir.
Okay, I noticed you created a table, and while creating a table, you partition it. So I just wanted to know if it's possible to partition an existing table.
Yeah, you can partition existing table too.
Oh, okay, all right. So when maybe when I'm opportune, you will show me how to partition an existing table.
Yes, but I'm so sorry because I'm not home now. I use my phone. I'm not using my computer. If I got time, I will show you.
All right, thank you.
You're welcome, brother.
Yeah, but at the same time, we're going to share the all the scripts with the group, with the class.
I don't know, is Mr. Gaitan still here?
No, he left. He sent us a message saying that he has to go.
Okay. Okay, guys, I think with that done, you guys will get the rest of the material in the group.
All right, we received it already.
Okay. Okay, bye-bye.
Bye-bye.
All right, thank you. So the class is over, right?
Yeah.
Oh, yeah, it's
Thank
over.
you,
I
Anita.
guess no class on Friday, so you guys have a
Yeah.
good week.
Hey,
Okay.
Anita.
Yeah.
Oh, you recorded, right?
Yep.
Okay.
Okay. Bye.
And the let me ask you.
Yes.
You guys going to send the script, right? Because about the explain plan.
I'll work on it.
Okay.
We'll work on it.
All right.
Okay. Thank you.
All right. Good to know. Thank you.